Guys, now, Ohm's law is a famous law example of a directly proportional relationship. It states in an electrical circuit as the voltage increases across the resistor, the current flowing through it increases. And you're like, okay, what does that mean? And then he goes, the following table shows the results of shielding obtained when performing an experiment to prove Ohm's law. So then all of a sudden you're going, oh wait a minute, they gave me numbers and they gave me a table. This is looking a bit more familiar now, isn't it? Numbers in a table. Now, graph these results putting the current on the x-axis and the voltage on the y-axis. So it actually gets a lot easier. So what it wants me to do, oh, this is really easy. Now, we can do something like this, guys. We can go down this far and then across. Now, I'm a bit out of range on my numbers here, so what I do, you guys have an easier time with this because you have it in a book. I'm going to just drag this down the bottom here. Whoop, not like that, I'm not. Now, bring this down with me. So these are the numbers I want to draw. So let's begin. It's told me which one's the x-axis? Current on the x-axis. Which one's current again? The one that goes as high as the number 6. So 1, 2, 3, 4, 5, and 6. Now guys, what do I label it? Current, and then I bracket in amps. Okay, that's no bother. Now, we do another one. Voltage. How high does voltage have to go up to? 19. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's handy enough, isn't it? Let's start off. What's the first point? First point? That's 0, 0. What's the second point? 1 and 1.5. The third point? 2, 3. The fourth point? 3 and 4.5. The fifth point? 4 and 6. That one there? 7. And there we go. Now, 0, 0, located here. 1. Now, how do I get to 1.5, guys? It's in between 1 and 2. This one here. Yeah. 2 and 3. 2 up, 3 there. 3 and 4.5. There you go. And then 4 and 6. Yeah, it's a straight line, isn't it? So why don't I just go all the way to 6 to 9 and then just do this? Yes. That's actually, Aaron, you're right. I made a mistake. What happened was, there we go. We got a translator in. It's grand. Now, there we go, guys. Ready? Now, explain how we know that voltage is directly proportional. What does that word directly proportional mean? Directly, it means it's a straight line. The graph is a straight line. Now, what happens next? Use your graph to estimate the voltage value for 4.5 amps. How do you do 4.5 amps, guys? That's voltage V. Where's 4.5 again? Halfway in between. Go up, across, and what do we get? About 6.5, 6.6. What do you guys get? 6.6 volts or 6.7, it doesn't matter. Now, 5.25 volts, 5.25 volts. Now, that's 5.5. Where's 5.25? In the middle of 5 and 5.5. Round here, hits, and then comes down. What do we think? About 3.5, yeah? 3.5. Good lads. Who got that? 3.5? Good man. Shh. Now, find the equation which represents the relationship between the voltage and the current. Okay, guys, y equals mx plus c. What's the C value? Y is a 0. Across the y-axis, that's 0. Shh. Okay, guys. What is the slope? Remember we did rise over run? Pick 2 points. We'll pick 6 and 9, won't we? And we'll pick 0, 0, yeah? Now, how many blocks do you go to the right? So it's 9 up and 6 across and 9 up. So what's the slope then? Remember, it's rise over run. So 6 over 9, which is the same thing as, somebody said 1.5, you're correct. Same thing as 3 over 2, or 1.5x. M stands for the slope. Thank you. So impressive work today, lads. Done. Use the equation of the graph to find the current when the voltage is 45. Now here we go, okay guys, here's the problem here, right? Is the voltage the Y value or the X value? Voltage is the Y value and current is the X value. So here's what happens. Whatever your voltage is, your voltage, which one's the bigger number, the voltage or the current? Look at the numbers, which one's always bigger? Voltage always seems to be a bigger number than current. So, when voltage is 45, are we expecting a bigger or smaller number for current? Smaller. So 45 equals 1.5 times the current. Now, how do I get X on its own? 1.5 multiplied by a number is 45. So what's the reverse of multiplication? So 45 divided by 1.5 equals X. Who got 30 last night? 30 amps? Aaron, how'd you do it?
I think I just
7. Okay. Newton's second law states that the acceleration of a body undergoes is directly proportional to the force applied to it. A student performed an experiment in which she applied a variety of forces and recorded its resulting acceleration in each case. The results she obtained are as follows. 1, 2.5. What's the next one then? 2, 5. Okay, now guys, have you noticed something? Every single time you go up 1, what happens to the force? Exactly. So every single time you go up 1, like one extra bit of acceleration gets you 2.5 newtons more of force. Would you agree with that? Now, we're going to draw this, okay, but we're going to, we have to label each one. That's not what we're looking for, is it? Now, so we're looking for something like this, and on the axis here. Now, 1 to 6 on the x-axis, isn't it? So 1, 2, 3, 4, 5, and 6. What's the label for that? And what's the units? ms minus 2? Same thing. Okay, but you will know that, yeah. So just write down what you said. What's on this axis? And it's in n. And it has to go as high as 15. So, yeah, I'll say we'll just go up like this. 1, 2, 3, 4, 5, 6. Will I fit all this in? 7, 8, 9, 10, 11, 12, 13. Oh, just about 14 and 15 at the very top. Now, we're going to draw the first point and the last point, yeah? So 1 goes with 2.5. Is there a 0, 0? No, there isn't. And then the last point, 6 goes with 15. Just make sure they're in line. Do you see the way you can draw it straight down to see if they're in line or not? And then 2.5 Then you can check that it's 15 on the way down and 6 the way up. I should start doing that more often. Now, link them together. And then what do we do next? Have it drawn all the points in, yeah? Everybody cool with that? Now, what happens next? How do we know that acceleration is directly proportional to force? Directly proportional? The graph is a straight line. Well done. Use your graph to find the force when the acceleration is 4. When is the acceleration 4? Acceleration, yeah? Hits it and goes across? 10. 10 what? 10 N. 10 newtons. See, it's in newtons. Use your graph to estimate the acceleration when the force is 6, Aaron. The force is 6. Force is 6. 6 newtons here. Bring it across and down. 3. 2.3, 2.4? Okay. 2.3 is 2.4. So it's underneath 2.5, isn't it? So about 2.3, 2.4. So call it 2.4, okay? Find the equation which represents the relationship between force and acceleration. Y equals mx plus c. What's the y value again? The y value is force and the x value is acceleration. Now, what's the c value? Where the line hits the y-axis. Yeah, it'd continue on to hit it at 0, 0, wouldn't it? So you can just continue on the line straight through and you see that hits at 0, 0. Okay, so the c value is 0. So what does that mean about the, how do we find out the m value? What's the slope? Now, for every single one you go up, how much do you go up in this one? 2.5. Now, if you weren't sure about that, you could always do rise over run. And what you could say is that if you compare this point here to this point here, how far do you go across? 1, 2, 3, 4, 5. You go 5 across, don't you? And then how many do you go up? You start at 3, and so you start at 2.5 and you end up at 15 minus 2.5 is 12.5. And then 12.5 divided by 5 is 2.5. You can still do rise over run. Okay. Now, that's the equation. In the experiment, the constant of proportionality, the slope of the line, represents the mass of the moving body. It basically means the slope is the mass of the body. The slope of the line represents the mass of the body. What is the mass of the body? 2.5 kilograms. Use the equation of the graph to find the acceleration of the body when the applied force is 40. 40. Now, which is the force again? Y or X? Which value is the force? Y. The Y value is 40. 40 equals 2.5 times the X value. So what's the X value? Joaquin? So, where were we? 40 equals 2.5 times X. So what is X? 40 divided by 2.5. X equals, Kenny? 16. 16 ms minus 2. Okay, guys. Yeah. 40 divided by 2.5 is 16. Okay.